Okay, good day. This is Math 140 College Algebra. I'm Professor McCulley. This is lesson 3.6 on modeling quadratic functions. Let's get to it. So today we are going to model quadratic functions through using a vertex and a point. We're going to use x-intercepts and a point. We're going to use 3 points, and we're going to do regression. So let's look at each of those individually. The first one is finding a quadratic equation given a vertex and a point. And so we're going to use the vertex. And if you remember, we have the vertex form was y equals a times the quantity x minus h squared plus k. The vertex is h and k. And we can use the point as an x and a y value. And we'll have 4 of the 5 variables. We'll solve for a, and then we'll rewrite the final equation. So what does that look like? Well, if I talk about given the vertex of 4, 1, and a parabola with 6, -7, a point on the parabola, find the equation of the parabola in vertex form. So that vertex form is going to be y equals a times x minus h quantity squared plus k. And our vertex, so the h, k values are going to be that 4, 1. And then the point, the x and the y value, is going to be 6, -7. So I can come in and I can plug all these things in. And so the y value is going to be that -7. I don't know what a is. X is 6, h is 4, and k is 1. So this doesn't look, it looks more like a 9, so let's fix that. And we'll go a, parentheses around it. All right, so let's evaluate this. 6 minus 4 is 2, and 2 squared is 4, so I have -7 equals 4a plus 1. Subtract 1 from both sides, I'll get -8 equals 4a. And when I divide both sides by 4, I'll get a equaling to -2. So now, again, if I'm following the steps from the previous one, come on, go back. I can use the vertex and the a value to rewrite the final equation. So I know what a is, so my final answer, y equals -2. And then it's going to be x. And so my h was 4, so x minus 4, quantity squared. And then plus k, and k is 1, so plus 1. And there is my final answer in vertex form. Finding the quadratic function using the x-intercepts and a point. So if we use the x-intercepts to plug in the x-intercepts and the point to find a, and then we're going to rewrite the function for the value a in the intercepts. So this is going to be very similar to the process that we did last time, except we're going to use a little bit different equation here. And we're kind of going to use the x-intercepts as factors of the polynomial function. And then this a value gives us the correct, I guess, slant of the graph. And what I mean by that is this. If I had two x-intercepts, let's say I called this one x-intercept and this my other intercept, there's an infinite number of parabolas that I could draw through it. So I could draw a parabola that looks like that through it. If I did one red, I could do one that's real shallow looking. Or I could even have a parabola that opens down. So I need that extra, I need to find out what A is to find the direction and how it opens. All right. So let's see here. Find two equations, one that opens up and one that opens down that has 3, 0 and 7, 0 as x-intercepts. So since it says find two equations, we can do that. We're just going to make up an a value that's going to work. And so I'm going to start with that y equals a times x minus m times x minus n. And in this case, my n value is going to be 3 and m is going to be 7, although I think it's backwards, but the order doesn't matter because it's multiplication. So I've got y equals a times x minus 3 and x minus 7, like that. And when I multiply these two things out, I'll get y equals a times x squared minus 10x plus 21. Minus 10x plus 21. I'm also, because x times x is x squared, x times -7 is -7x, 3 times x is -3x plus the -7x gives me the -10, and then negative times negative is positive. 3 times 7 is 21. So just to make it simple, my two equations, my first one is first equation, let a equal 1, and so I'll just have y equals x squared minus 10x plus 21. This one opens up, and then for my second equation, let a equal -1. So I'll go y equals -1 times x squared minus 10x plus 21, and we'll go y equals -x squared plus 10x minus 21. And those will be my two. This one opens down. This one opens up. All right. Okay, so if we're given 3 points to model a quadratic function, I'm going to use matrices here, but we're going to plug the 3 points into 3 separate quadratic equations. We're going to set up 3 linear equations to solve for the unknown coefficients. We're going to use matrices to find those coefficients, and then we're going to rewrite the final function using the coefficients that we find in step 3. So what does that look like? Well, if I'm given an example where I say find the equation of a parabola that passes through the points 1, 3, 2, 5, and 5, 47, we know that our generalized quadratic function looks like this: ax squared plus bx plus c equaling to y. And each of these points tell me that when I plug 1 in for x here and here, I'll get 3 out. When I plug 2 in for x here and here, I'll get 5 out. When I plug 5 in for x here and here, I'll get 47 out. All right, so the way that that's going to look is if I go a times 1 squared plus b times 1 plus c, I'm going to get 3, excuse me. And then when I go a times 2 squared plus b times 2 plus c, I want to get 5. And then when I go a times 5 squared plus b times 5 plus c, I'm going to get 47. All right, so if I square all this stuff out and I rewrite it, I'll get a plus b plus c is equal to 3. 2 squared is 4, so I'll have 4a plus 2 times b is 2b plus c equaling to 5. And then 5 squared is 25, so I'll have 25a plus 5b plus c equaling to 47. Now here are my linear equations, and even though they have 3 variables in them, they are linear equations because all of the degrees of each of the 3 variables is 1. And so with this, I am going to make 2 different matrices. I'm going to make what I call my coefficients, COEFFICINT matrix, and a constants matrix, so CONSTANTS. And the coefficient matrix is going to be a 3 by 3 matrix, and it has 3 rows and 3 columns, and it's just going to be the coefficients of all of these values in proper order. So the top row will be 1, 1, 1 because the coefficients of these are all 1. And again, we wouldn't write 1 as a final answer, but this isn't a final answer, so we're going to leave it. Then that second row is going to be 4, 2, 1, and then this last row will be 25, 5, and then 1. And then our constants matrix is just going to be these constants over here. So 3, 5, 47. And so it has 3 rows and only 1 constant. Now we're going to use the graphing calculator to do the work for us. So let's clear this all out here. Quit. Let's clear this. And so first thing I want to do is I want to find the matrix stuff. And if you were in my Honors Algebra 2 class last year, you have this matrix button. You've seen it. So I want to go second. And I hit this matrix button here. And this is the X inverse button, is its normal function. And you'll see I have 3 menu tops here. First one is names, second one is math, the third one is edit. The math one we're not going to use at all. The edit is how you get the data into the matrices, and the names are how you do your simple operations on them. So I'm going to pop over here to edit, and I'm going to hit 1 for matrix, and we have one that's already been put in here. It's a 3x3 matrix, and so just to review how to enter that, I can hit 3 and I hit enter and it moves over. I hit 3 and hit enter and it moves over. But if it was already a 3x3, you can just use your arrow keys to bop around wherever. And if I wanted it to be a 2x3 matrix, I could go over here and hit 2, and if I hit enter and it changes it. So if I go back, I can hit 3 and it changes it back for me. So entering those coefficients, it was 1, hit enter, 1, hit enter, 1, hit enter, and then the next one was 4, 2, and then 1. And the last one was 25, 5, and then 1. And so now we want to quit. We want to do that again. So second matrix, we want to go over to edit. We're going to hit 2 this time. We need a 3x1 matrix, and we need 3, we need 5, we need 47, I think. I need to check that, so let's delete that 47 before I go too much further. I need 3, 5, and 47. Okay, this should work. So let's hit quit. And now to do the operations, I'm going to again hit second matrix. And now we're going to stay in the names column because we want to do that matrix. And what we want to do here is we want to bring up the A matrix. We want to take the inverse of that, and then we're going to multiply that by what we call the B matrix. And what that's going to give us is our A, our B, and our C. All right, so let's go ahead and do that. You're going to hit A. There's my A. I'm going to hit that X inverse button. I'm going to hit the multiplication, and now I need to get B. So again, second, hit that matrix. Hit 2 there. Now I have my A inverse B. I hit enter. I get 3. I get -7. I get 7. That is my A value, my B value, my C value. And we get here, it was 3, -7, and 7. So my final answer for this is going to be y equal to 3x squared minus 7x plus 7. And that is my final answer. All right, last question here. It says use the table below to find a parabolic regression curve for the following data. And so I have a set of data here that I want to enter in, and we've already done a linear regression. I want to review that process. So we come back to our graphing calculator, and all of the regression capabilities of the graphing calculator are in this under this stat button. So we're going to hit stat there. And the first thing we want to do is we always want to clear out the list because we don't know who put data in there before. So I'm going to hit for clear list. Now we got to tell it what list to clear out. And if you look here at the top of your numbers here, L1, L2, L3, L4, L5, and L6, those are 6 different data lists that you can create at one time. We only need to do L1 and L2, so I'm going to hit second. I'm going to hit 1. That's going to have me clear out list 1. I'm going to hit the comma button. Second, hit 2. That's going to have me clear out list 2. I'm going to hit enter. It's going to say done. I'm going to hit stat. Now we're going to edit. And we see there's no data in there, so we're going to move over to 1. And again, they give us the data horizontally. We're going to enter it vertically. So our X list is going to be just this list here, 1, 2, 3, 4, 5, 6, 7. So that's easy. 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, enter, and then 7, enter. And hit my right arrow key. That'll bring me into list 2. And so 10, 5, 4. So I'll do those first. So 10, 5, and then 4, and I've got that in there, and then 2, 0, 1, 6, so 2, 0, oops, I don't need a negative sign, let's delete that, enter, 2, 0, 1, and then 6, I think that's correct, let's check again, 2, 0, 1, 6, we're good, and so both of my columns have an X and a Y value. That looks good. Hit my stat button. We're going to go over to calculate. And we've already done linear regression, AX plus B. We want a quadratic function, so we're going to do a quadratic regression right here. And so we're going to hit 5. We need the X's values in L1, the Y values in N2. It's got a frequency list here, so I must have been doing that for stats. We want to make sure that that is empty because we don't have a frequency list. And we don't need to store the regression equation. We're just going to hit enter to calculate there. And so, again, this isn't going to be perfect, but my A value is going to be 0.714, my B value negative 6.574, and my C value equaling to 16. So let's write that as a final equation. Y equal to negative 0.714 squared plus, actually should be minus, so let's do that, let's clear this out, minus 6.571, minus 6.571x, and then plus, I had 16 there at the end. That is my equation, and I am done with that. And so that is all I've got for this particular lesson, folks. So today's Marvel fun fact of the day: during the suit color change scene of Captain Marvel, the color choices by the young Monica Rambeau may seem random, but they all have a different significance. The red and yellow she first picked is the same colors as DC's Shazam, who used to have the same moniker of Captain Marvel pre-2000s. The second color, black and gold, that was a reference to Carol Danvers' colors that she had wore earlier as Ms. Marvel. And then finally, the green and white colors that were chosen are the original colors as the original male version of Captain Marvel, Marvel, the Kree warrior, and his suit from the 1960s. Well, that's all I got for today, folks. Have a good day. Bye.